All right, we're going to do a few things today. First, we're going to go way back and take a look at our simulator program, and we're going to see how what we learned there is going to help us solve a couple of missions with our real robots. Then we're going to go ahead and we're going to look at our sensors again, both the line sensor and the block sensor is what we're going to call it, the one behind our left wheel, and also that light sensor, and we're going to talk about how those things can help you find your way around the field for competition. Now, you'll recall that when we were using BYOB, we wrote a little program that made our robot go out to this dot, stop for a second, and then back up and come back to home base. And I've got part of that written here, and I'm going to do this when the space key is pressed, and I'm going to turn on my left motor at 180, my right motor at 0, and of course you probably have a subroutine that will do that now. I'm going to wait 4 seconds. Now, that wait 4 seconds is the amount of time it takes for my robot to get out to that dot. And then I'm going to stop for 1 second, and let's go ahead and finish this program up. Now we want to back up, and you probably, again, have a subroutine that will help you back up. But in that subroutine, it would be left motor 0, right motor 180. And we're going to drive backwards and get to home base again. And that should take, again, about 4 seconds to get back to home base. Took us 4 seconds to get out to the dot, and it should take 4 seconds to get back to the dot. Now, your real robot might not work that way, but you're just going to have to experiment with that. And then when we get back to home base, we are just going to stop, okay? So that is going to be a lot like our sign mission, right? We're just going to push a sign out to the edge of the field, and we're going to drop it off out there, and then we're going to back up and come back home to base, okay? So follow this same pattern, and you can use your subroutines rather than using these stacks of blocks like I used here, and this should work. If we push our space key here, we should be able to drive out to the dot and back up. So there's that program. What we learned so long ago is really all you need to know to do, say, the sign mission or any other mission you might want to do something like that with. Think about the popcorn mission where you drive out for a period of time, you stop. In that case, you're maybe going to put an arm down to collect the popcorn, and then just back up and drive back to base. So this is real useful for you if you realize that you just use the weights in there, and you can go approximately where you want to go. Okay, so let's shift gears now. I've got RoboBlocks up, and I've got the robot connected, and I've got my team file open. It's got my movement subroutines in it. It's got my remote control program, and it's got part of my intro mission written here. But let's go ahead and extend what we were just doing in BYOB to our main program here. I'm going to duplicate this intro mission, so I have another block that looks just the same. I'm going to get rid of the intro mission code that's inside of there and edit the sprite here to say, well, let's call it the sign mission, okay? So let's change this to sign mission and say, okay. All right? So now I've got this nice clean slate for my sign mission, and we discovered that out in BYOB, we're able to just drive forward and wait a number of seconds and then stop and then drive backwards. And we can do the same thing here in RoboBlocks. And the way we're going to do that, I'm already using S to stop my robot in my remote control. So I'm going to choose a different letter. And let's go ahead and choose O for open sign. That's what those signs are. It's an open sign. So when O is pressed, that's going to be our sign mission. And what I'm going to do is I am going to drive out forward, right, full speed, for however many seconds it takes me to get out to where I want to leave the sign. And let's just say that it is 5 seconds. You can put a decimal point there if it's a little more than 5 seconds. So you can use decimal points in your wait times. And when I get out there, I am going to call my subroutine stop. So that's pretty simple. See how much simpler this is when we use our subroutines. And once I get out there, I maybe want to wait out there for half a second so everything kind of settles down and I can drop off my sign. And then I'm just going to go ahead and back up and come back home. And that should be about 5 seconds to get back home. And let's just make sure that we do indeed get back into home base. And let's wait 6 seconds. Okay, so let's take a look at this again. When we press the O key, we are going to go forward for 5 seconds. And then we're going to stop for half a second. We're going to drop off the sign in that case. Then we're going to go backwards for 6 seconds, which is going to get us back home. So there you've got your sign mission. I'm sure your times are going to be different than this, but that's all you need to do your sign mission. Now, a lot of you seem real fuzzy still on how we use our line sensors and our other sensors to get out to the stage. I'm going to go here to my intro mission. And if you're having trouble on a line sensor, well, go ahead and watch that last video that we had out there because I explained the whole thing. But I want to one more time do this, and that is we're going to see how we can take a look at what's happening with our sensors so we get a real good idea on how to set our sensors. So I'm going to have a forever loop, and forever I am going to update my pin 5 sensor because that's where my line sensor is. And I'm going to display my pin 5 sensor out on the stage. And I can forever update that. And if there is something black under my line sensor in this case, it's going to have a high number. If there's something white under my line sensor, it's going to have a low number. And sometimes it's a good idea to take a look at what those high numbers are. For instance, on our magic marker fields, our high numbers are nowhere near in these 200s like this. They're maybe down in the 100 range. So you're going to want to change where your robot switches the direction. And the way we change that is by using this setup line follow. Okay, by default, it is set at 150, the brightness at which your robot will change direction. And if you're having trouble line following on the magic marker fields, put that down at about 75 or so. And if we double click this, that sends that information down to your Arduino, and now you are set to switch at 75. Now, if that goes too low, you're going to start line following along the tiny little gray lines and so forth that are along your field. So you're going to need to experiment with this number a little bit until you get a real reliable number in there for line following in your light conditions and whatever kind of lines are on your field. Let's go ahead and move this pin 5 sensor off the stage and go back to sensing here. And now we want to look at our light sensor, which in my case is in pin 0. And we're going to forever update pin 0 now. And you'll see that when we do that, we're getting a number back from our light sensor, and depending on where we point our robot, the number goes down as we get closer to different light situations. We've got a light down by the roller coaster. We've got a light over by the Ferris wheel. So what we're going to do to figure out where we want to stop is position our robot as such where we want to be when we stop, and set up this forever loop and read pin 0 or wherever you have your LDR sensor plugged in, and whatever number comes back right there, that's the number at which you want to stop. Okay? So let's say it is 60. That was the case, I think the other day in the classroom. It was 60 where I wanted to stop, where my LDR sensor was in the exact right spot to do whatever I was going to do with the roller coaster. So what I did is I went to my movement subroutines, and duplicated this drive to stage block. That's the one we had out on open source. And I duplicated it and I renamed it. I just went here and made a new name for this subroutine, and I called it Drive to Coaster. And this time, instead of looking at pin 3, instead of looking at pin 5, which is our line sensor, I'm looking at pin 0, which is our LDR sensor. So I'm going to use that same routine. When I start up, I'm just going to read that LDR sensor 10 times. It goes really, really fast. I'm going to wait just a little short amount of time. I'm going to follow the right side of the line until my sensor at pin 0 goes below 60. If it is below 60, I know I am where I want to be because that LDR sensor is sensing something below 60. And as soon as it does sense something below 60, I stop following. Let's explain this block one more time. We need to update that sensor over and over and over again, or it will remain at the same value it was at the last time we looked at it up here when we updated it. So we need to be looking at this, looking at this, looking at this, looking at this the whole time we are following the right side of the line. That's what this little block does. And as soon as we get less than 60, which is where we want to be, we stop. So now we've got a subroutine we can use called Drive to Coaster that brings us out to the same spot every single time that we decide to drive out to the roller coaster and do that mission. Let's click back here on the intro mission and how we're going to do this. I'm going to get rid of this set up the line follow. I don't need to do that now. And this forever loop I was looking at my sensors with. And we're going to talk about my code for getting out to the stage and then playing my intro that I made in Speakonia. I am going to use the I key to get out to the stage. Okay, so when I press the I key, I'm going to call my drive to stage subroutine, which is over here. That's that open source thing. And that should get you out to the stage provided your sensors are set right. So it's going to call that drive to stage subroutine, and when I get to that edge, I always like to put these little weights in there so I can see to make sure everything is happening right. So I'm going to wait a half a second here, and then I'm going to go forward. I need to get to the middle of the stage, so I'm going to go forward for 1 second. That's how long it takes for me to get from the edge of the stage where I am stopped now to the middle of the stage. And then I'm going to spin right until I become square with the audience. I want to be facing the audience. So I need to spin around and look at the audience. So in my case, I'm going to spin right for half a second, and that will get me out to where I want to be, or facing the audience, and then I'm going to stop. Then I'm going to play my intro sound. And remember, the way that I use that sound was go here to sounds, and I said import, and then I found that wave file that I created with Speakonia, and I went ahead and I imported it. I don't have it here on my computer, but that's how you do it. You go to import, find that wave file. I had put mine on the desktop originally, and go ahead and import it. And then in your scripts under sound, you're going to have this block, play sound. That's what I've got there at the bottom, and you're going to add that to the bottom, and then your robot will start speaking. Now, next time we're going to talk about how to coordinate the motors and the lights with the speaking as well. All right, next I'm going to talk a little bit about Speakonia. Speakonia you're going to find under CFS Technologies in your Start menu. And pretty much all you do is type in words here, and this, what's called a speech or a text-to-speech engine, converts the words into speech. So I want to say, hello, I am a robot, okay? And I want to be able to customize how this how my robot says these things. Okay, I don't know if you're going to be able to hear that on this or not, but it just did it in a voice. Let's say I want to change that voice. I go over here and I choose, say, Sam, and I say apply, and now my voice is Sam. But let's say I want to change the pitch of Sam. I want to give him a really, really deep voice, so I do that.
Okay.
Yeah, see what that does?
Hello, I am a robot.
And now I've got that really, really deep voice. So I can change the pitch to real low or real high. And don't forget to push the apply here, and that changes Sam's voice. Okay? So once you get all your script in here, remember it needs to be below 45 seconds. You go to File and then Save as WAV file. And you give it a file name. And I'm just going to call mine intro, and I'm going to put it in my documents. So put it somewhere that you can find it, and then just say export. And that exports the Speakonia file. Whatever you typed in here, the whole thing is now a WAV file. It's almost like an MP3, and it's wherever you saved it. And in my case, I am not going to save the changes to this file. You can save it in your team folder. And again, to get that into RoboBlocks, you go to Sounds, and then you import that sound into your RoboBlocks program. And you go ahead and you play that sound here under the sound blocks. So hopefully this helps out. Make sure if you've got questions, don't be afraid to email me. You use the Contact Us on the Fondy Heat website, or even give me a call if you want to do that. That's just fine too. So hopefully we'll see you next time at Robotics.